The most common operation in making data models in every language but Tableau is joins. So joins are incredibly powerful operations that allow us to merge data frames based on shared columns or single column. There's a bunch of different flavors we're going to walk our way through, and we're going to take like an investigative approach of this, of seeing examples and kind of backing out what the join is actually doing for each one of the flavors. So imagine we've got two data sheets, and this is kind of the conventional terminology, left and right, and we're going to take these and make these into a result. By the way, these are all from the Pandas help page. Pandas is the Python data science package, and it's really good. It's what I use for most of my work, and these are just their kind of, I didn't make these. These are from Pandas. Okay, so we've got left and we've got right, and we have result. Okay, so let's do some detective work. First of all, notice that left and right share a column called key. They even share values in that column. We've got K0, K1, K2, and K3, and we happen to have the same values in right. That's great. Now, or that's interesting, let's say. Yet to be seen if it's great. They also have different columns, right? So left has A and B, and right has C and D. And notice what's happened. In result, I have 4 columns, A, B, C, D, all of the columns contained in left and all of the columns contained in right. And somehow it knows that the first row of left should be put in the same as the first row in right. So what's going on here? How does this work? Well, what's happened is, actually, let's go back. So what's happened here is it's identified the fact that the key is shared here. So we've got K0 here, K0 here. So it's going to say, okay, I see the same key in both places, and therefore I'm going to put these things in the same row. I see the same key, K1 here, and so I'm going to put A1 and B1 in the same row as C1 and D1, and so on and so on. Now notice what's really cool about this. If it's matching key values, the keys could be in different orders. I don't have to just kind of smash the columns together. The join is going to do an intelligent lookup. So if this was, K0 down here at the bottom rather than the top, the join would completely be able to roll with that. But it also leads to some interesting and maybe unexpected behavior that we kind of have to wrestle with, and turns out to be really important. So imagine we have 2 key columns instead. We've got key 1 and key 2. So notice that both left and right have both of these. And we've got our result. Again, the result has all the columns contained in left and all the columns contained in right. But notice what's happened here. We've got a duplicate. And what do I mean by that? Well, let's start at the top. So I've got K, and we're going to use both of these. So the key is a pair now. So I have K0, K0. Okay, that's good. I've got K0 and K0 here. All right, so then that's going to be my first row. A0, B0, C0, D0. Perfect. Okay, the next thing the join says, it looks in left and says, okay, I've got K0, K1. Do I have that key anywhere? I do not have that key anywhere. I don't have K0, K1. I have K1, K0, but the order matters. So it basically says, okay, I don't see a match. I'm going to throw this one away. And then it says, okay, I've got K1, K0 here, but I have 2 of them here. So what do I do in that situation? Well, I do both of them. So I do A2, B2, C1, D1, because that's a match. That's the first one. And I do A2, B2, C2, D2, because that's also a key match. So notice that I have a duplicate key now. Why? Because I had a duplicate value of that key inside right. So even though it was contained only once in left, I have it twice in right. So we can get some blow up. We'll talk about that a little bit more. And then we go down to the last one, K2, K1. Oh, nothing, K2, K0. So notice here in this particular type of join, we both have drops. We can have unique matches like we did with K0, K0. We have drops like we did with K0, K1 and K2, K1. And we have duplicates where we have K1, K0 getting duplicated twice because it was contained twice in right. So this is pretty interesting. So this is basically what we just talked about. But I just want to point out here that if I have, let's say, KL copies of a key in left and KR copies of that key in right, then in the resulting data frame, I will have KL times KR rows associated with that key. And so in this case, KL was 1. I had 1 copy of the key over here. KR was 2. I had 2 copies of the key over here. And therefore, I have 2 copies of the key in the resulting data frame. But this number could get quite large, right? If I have 10 over here and 20 over here, I'm going to have 200 in the result. And that can really blow up on us. So the way we choose what to keep and what to throw determines the flavor of the join. So in an inner join, which is the one we've been doing so far, we only keep rows where the key appears both in left and right. It's like if you think about a Venn diagram of the keys that are in left and the keys that are in right, the inner join is the intersection of that key space. So this is why we call it inner. It's like the inner part of the Venn diagram. So only the keys that were shared between the two. If we do a left join, we keep all of the keys that were in left and then try to find matches in right. And if we can't, we do a missing value. So for instance, the key K0, K1 is included in left, but it is not included in right. And so when I insert that key into the result, I just have to put nan, or whatever the value of missing value is in your particular programming language in columns C and D. So, and there are cases where this is really important. We'll see several over the course of the semester where it's like, oh no, you really need a left join here, or you really need a right join here. And I've also seen it, many, many times in various projects where you actually want these missing values to be present. Same thing with K2, K1. So K2, K1 is contained in left, but not contained in right, and therefore we keep it, even if we have to insert missing values. Right is exactly the opposite. We keep all the keys in right, even if it means that we have to insert missing values in the columns of left. It's exactly the opposite. And then outer is we keep all the keys in both of them, inserting missing values where we need. So outer is like the outer part of the Venn diagram. We keep all of the possible keys. So notice K0, K0 is fine. K0, K1 is included in left but not in right. So we have missing values in C and D. And K2, K1, K2, K0 is contained in right but not left. And so we have missing values in the columns of left. So again, we can kind of do this any way we want, and Tableau will support us regardless of what our choice is. Now, the issue here is that, there are tons of issues. One of the biggest issues is that if you're not careful with writing your joins carefully, this duplication of keys can make your data frame explode. And this is one of the primary reasons that Tableau uses relationships. Because you don't actually have to make the table when the user's formulating the data model, you kind of avoid the case where you make a big, giant, huge duplicated table and then never really use it. So Tableau is trying to be smart about what it actually creates in memory so that your computer doesn't light on fire. I have a brother that worked for Azure at Microsoft, their cloud computing software, and a lot of his job at one point in his career was looking through people's SQL code and trying to find the places where they were being really dumb about their joins. I'm not kidding. It's like, oh, this is why. Because you're trying to make 65 trillion rows and the computer is upset with you. Like, if we just change this a little bit, like everything will be okay. So we need to be careful. So the big idea is let Tableau deal with things if we can, like use relationships where you can, and use joins where you can't. So we're going to see an example here in a moment where we don't really have a choice in the matter. We have to use a join because the relationship won't work, but where we can, we should allow Tableau to make the choice for us.